slides here, and we'll spend the next about half hour going through this session on gNMI. Yes, gNMI oh my, right? This is an introduction to the gNMI-based microservices on iOS XE. This is a 200 level course, so I'm skipping a little bit of introduction. We're going into some more deeper technical things around this particular API. But my intent here is that you walk away from the session with a much better understanding of this API, what you can do with it, how you can use it, how you can work with it effectively in production. This is what we're going to be covering for the next half hour or so. We'll give an introduction to the programmability lifecycle on iOS XE. We'll talk about the API on your 9300 switches or on your iOS ISR, ASRs, on your 8300 series of routers. Then we'll talk about gNMI specifically. What do I need to know? What do I need to know about this API? How long has it been around? What's some of the innovation that we've added over the years? And then just some tips and tricks for using it in production. We'll talk about gNOI, the operations part of network management. The gNOI, there's kind of three main functions of gNOI, which is the certificate management, operating system image upgrade, and factory reset. So I have some demo slides in here that describe this API and also demonstrate the capabilities and the use of doing these three functions. We'll talk about the tunnel.proto. Tunnel.proto so that we can dial out from our network device to a central tooling so that all of our network devices can be managed centrally. We'll spend some time in Yang Suite. If you haven't seen Yang Suite, it's the tooling that we use for all of our API testing and validation internally in Cisco. We also publish this tool so that you can use it and do API validation yourself. And then we'll talk about resources, right? I have some environments that you can reserve that you can get into to get hands on this feature, as well as some labs and some other documentation that will really help. So as far as the programmability and automation lifecycle goes on iOS XE, there's quite a rich feature set. On the top right side of this, we have the core API. Right? This is our NETCONF API. This is our REST API, that's backed by the Yang data models. gNMI and all of the Yang native data models are all part of the core API. On the bottom right is the device monitoring. There's a small component of gNMI for telemetry. We'll touch on telemetry just a little bit today, but it's really not the focus of this presentation. If you are more curious about telemetry, specifically telemetry with gNMI, there are some other sessions that we've delivered this week, and you'll see those in the end of the session. I have a slide that has 5 or 6 other sessions that are related to this portfolio. Now, as far as the programmable interfaces go on iOS XE, like 99% of the time, we're going to interact with the device how? Using SSH, right? CLI, either telnet or SSH into it and send CLI commands. Maybe we're going to use some SNMP. Maybe we're actually going to click around in the web UI. And these are all traditional ways of monitoring and managing the device. But we can talk about the programmatic ways, right? The device-to-device or the machine-to-machine interfaces, which are shown here as NETCONF, RESTCONF, and gNMI. These are the same core APIs that have been available on iOS XE for quite some time, since early days in 16. And all of these APIs, they're all backed up by the same data. The same data models are available regardless of which API interface you use. So if you're using, if you have a telemetry use case with NETCONF, or if you have a telemetry use case with gNMI, it's the same data that's going to get exposed over these different interfaces. So what TCP ports do these APIs use? So by default, NETCONF is going to listen on this TCP port 830. The REST API, of course, we know REST listens on 80 or 443. And then gNMI, it did have a number assigned to it from IANA, the number authority, within the past couple of years. So it's 9339 is the standard TCP port where you're going to see gNMI listening on. There's one other TCP port that you might see for gNMI. We actually have 2 implementations on iOS XE. One is the secured implementation, which is 9339. And then we have a non-secured implementation, a non-standard, a non-RFC, if you will, implementation, which uses a different TCP port. You'll find that in the config guide. By default, it listens on 50052. Again, all of these ports are completely customizable. So I mentioned the telemetry interfaces, same thing, just like the APIs, you have a couple different telemetry interfaces where you're able to get telemetry off of the device. You can either push it off of the device, where there's a service listening out there on the network that's going to catch that telemetry, or you can dial in. You can make a TCP session into the device over that gNMI session, over that phone call, and once that phone call is answered, you can subscribe. You can say, hey, device, every 10 seconds, I want you to push me this specific type of data. This interface counter data, for example, is one of the most common use cases. So we have some differences between gRPC and gNMI. I have a slide coming up that describes gRPC and the protocol buffers and some of the technical implementation of these features. But I just wanted to call out the two main differences here for these gRPC-based telemetry interfaces. gRPC, dial out, very commonly used. It's a traditional feature that we configure like every other CLI. Conft, telemetry, blah, 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 end, right? And now we're pushing telemetry. Whereas with dial in, that conversation, that configuration is completely up to the caller who dials into the device, the caller who authenticates to the device, and the caller who then subscribes to specific information at a specific update interval. So talking a little bit about the data models. These Yang data models have been published on GitHub for pretty much every release, but really they reside inside your device. So when you load iOS XE, when you do a software upgrade from 16.12 to 17.3, for example, the data models are also upgraded with that software image upgrade. I put a couple notable data models on here, some of the most common ones, like interfaces opper, like I mentioned. We also have some events opper, so we can actually understand when events are happening on the device, like an optic fault occurs. If a fan fails or a line card is removed, we can get an event pushed to us for that. Or we can, of course, just do a get against the API to understand the state of all the line cards. Some of the most common data models on here I've called out, which is the Cisco iOS XE native.yang. This is the equivalent of the running config. Right? So show run equivalent is Cisco iOS XE native.yang. We can do a get or subscribe to this data model, and we'll understand exactly what's in the running config. We can do a set and update things like the host name, like routing protocols, like managing any feature. Again, all of these APIs, they all access the same set of base data models. But what is different between these APIs is the operations. At the end of the day, we're still doing the same function. We're still accomplishing the same goal. But the verb that we send to the API is slightly different, whether that's going to be a get. I guess the get's pretty standard across the board. But when we go talk about edit config, you can put or patch. With gNMI, it's just a single set operation. You have a couple of different options for what you're going to set. You can do a set delete, which marks it as deleted. You can do a set update, which is only going to change the specific things that you're changing. Or you can do a set replace, right? That's going to discard everything that you don't give it and only take what you do. There is telemetry operations that are supported in here as well. They establish subscription, subscribe. And with gRPC, it's a Yang push. It's an IETF standard that we've implemented, which is part of IETF. That's an overview of the APIs. Let's dig a little bit deeper specifically now into the gNMI API. This API supports a couple operations like we saw, specifically the capabilities exchange. What do you support? What data models does this API support? So we can ask the API, hey, what are your capabilities? And it'll give you back a really long list of like 600 data models, right? So then you can know, oh, you support this data model. Now I'm going to go do a get against this data model and understand the data that's actually coming. Like I mentioned with the set, it's a set update, set replace, or set delete. And the gets are pretty standard. You do have some options within the protocol to say if you want operational data or configuration data. So that is just one option that you have. But for the most part, the get works for like 99% of use cases. There's been quite a lot of evolution in the gRPC-based microservices on iOS XE over the years. Right? We first started shipping this feature set in 16.8 when the teams at Google started inventing this and ratifying it as part of the OpenConfig consortium. We started putting in the core API capability then as it was ratified, which was just get and set. Right? You could only do edit and config management operations. And then over the years, the protocol has matured. There's been more features that have been implemented or ratified or agreed upon by the consortium. And then vendors like Cisco have taken those specs and then implemented them into the products. And here you can see just a little bit of history of how we've added support for telemetry, subscribe, as well as some certificate and some authentication options, and then some additional protocol encoding options as well to have a more streamlined or more binary encoding so we can send more data over the wire and utilize less resources. The terminology with all of this Google stuff can get pretty confusing pretty quickly. So I put a slide in here that just calls out what exactly all of these G acronyms actually stand for, how they're used or what they're used for, and then, if applicable, when they came into the iOS XE product. What's important to note here is probably the very bottom line, which is the gNXI. So around the 17.3 timeframe is when gNOI was introduced, the operations interface. And it became apparent that there's going to be a whole lot of G ** I type of interfaces being developed or ratified by the Google consortium. So it was then when we renamed the CLI in our products. So prior to 17.3, you would type gNMI. After 17.3, it's gNXI, X being the star or the all-encompassing catch-all for all of the Google-based microservices. These gRPC-based microservices operate with these things called Google Protocol Buffers, GPB. That's how we actually serialize and wrap the data and then encapsulate it and message and send it over the wire. It's a relatively common form of protocol buffers, not so much in networking. We see this a lot in application developers, but not so much in networking. So if you do have like a set of software engineers and you talk to them about gRPC messaging, it's very common that they'll understand what you're talking about because they'll use this for sending information back and forth. So just a little bit on gRPC and gNMI. Again, gRPC is a messaging format, and then gNMI takes that messaging format and operationalizes it into a management interface. What does that look like on the actual configuration of the device? So on the left, we have an example CLI of gRPC dial-out telemetry. As I mentioned, it's a traditional CLI that you're going to be familiar with. Maybe you might not be familiar with it, but it's like every other set of CLIs or every other feature that you configure on iOS XE, where you blast in a couple lines of CLI that configure the feature and send the data to where you need it to go. If you compare that with gNMI, it's a network management interface. As I mentioned, it listens on the standard port 9339. We have 3 or 4 CLIs to enable this API, right? Once we run these CLIs, it's listening. Now we can connect into it and start sending commands like get, set, or subscribe. Here's an example, 50052 of the insecure port. So you can turn this port on where it validates your TLS and it validates your certificates, which is the standard, right? That's the only way to work with gNMI is you must do certificate-based authentication and validation per the protocol. That's a little cumbersome. Sometimes we want to just work with the API and we don't really care about certificates, especially when we're network adjacent or when we're at labs or proof of concepts. So at Cisco, we engineered a solution to gNMI that does not validate certificates. As a result, we run a second daemon on this 50052 port so that you can do those very easy workflows without having to manage certificates. Don't run this in production, right? This is for in your lab when you're just trying to understand how the tooling works, how the API works, and how the certificate management works. When you move into production, absolutely, you're going to want to run secure trust points. You're going to want to run certificate validation. You have options to do mutual TLS as well. So you can mutually validate your TLS connection between the client and the server and the client, two-way validation. We also have a secure init CLI. You can run this CLI, and it's going to generate a self-signed certificate for you. You can use that certificate one time only. That self-signed certificate is good for one workflow, and that is to install a properly signed certificate. Okay, so this secure init just helps you to bootstrap the service so you can have a secure connection to it to then send an actual certificate that is used for the rest of your transactions. So gNXI, as I mentioned, it was renamed in 17.3. Put a couple of screenshot examples on here so we can understand what it looks like when we have this feature enabled and configured. On the top left here, we see that the server is disabled on port 50052, right? I'm not using the non-standard service, but in this case, I do have the server enabled on port 9339. Further down in the show state detail, it tells me all the operational states of the microservices. of gNMI, the gRPC server, the config service, and the telemetry service. Right? These are all an Opera-enabled up state. And then the links to the actual specific tooling that we can use to interact with these microservices. And we'll get to that in a little bit when we talk about gNOI. But if you're using the gNXI API in production, put a slide in here that talks about some of the considerations that you might want to take into account before you actually move into production. Specifically, do you want to authenticate your users with a username and a password? Or do you want to authenticate your users with a username and a password and a certificate? Okay, so that's one option that you have. Do you want to authenticate your users locally, or do you want to authenticate them up at a TACACS level or a radius? Well, once your user is logged in, do you want to restrict what operations they can perform? Can they perform complete configuration management use cases? Can they manage only a certain part of the configuration? Can they manage none of the configuration? Are we only allowed to do telemetry? Are we only allowed to do factory resets? Right? These are all things that we can control using NACM or the role-based access control. We can also put an ACL in front of your gNMI microservice to prevent any IP address from coming into it. As part of NACM, we recommend to have two users. One is going to be your read-only user. Your read-only user, well, he's read-only. He can only subscribe to telemetry. He can do get operations against the configuration, but he's not able to affect any change. That's when we have our admin user, our priv15 user. He can do everything, including manage the NACM or manage the role-based access control rule set. So speaking a little bit more about the API, the role-based access control, we added a CLI in 17.5 up here to populate read rules. So you can run this CLI, and it's going to turn the knobs on the access control mechanism so that you can only have read-only operations for the users at the privilege level that you specify. All right, so this makes it really easy to lock down the API so that your users can only have limited operations. Once they have these limited operations, it's a little bit easier to tune those rules to allow them to do just the certain things that you want them to do, if that's part of your use case. What does that actually look like, the network access control module? I put an excerpt of the RPC that we actually send to the device to configure the access control mechanism. So I've mentioned gNOI. gNOI is the gRPC network operations interface. Network operations there's a bunch that are defined. There's about 20 operations that are defined in the consortium. However, in iOS XE, we've implemented just 3 of these. If there's others that you're using or that you're interested in, let me know, let us know so that we can prioritize those. The first three that we've prioritized are the certificate management API, the operating system image upgrade API, and the factory reset API. These are like pretty powerful APIs. Like it's not very often we need to send factory reset operations. It's not very often we need to do operating system image upgrades. And anytime you are working with certs, and crypto is probably not your favorite day of the week, right? But all of these APIs really help manage the lifecycle of these features. Right? The certificate management one essentially is just an API that only eats certificates. You can do revokes and you can do certificate management of the lifecycle through there. This is an example. This is an example of using this API. At the very top, I have my I guess it's Linux command. I'm calling the gNOI cert binary, and I'm calling the tool that connects to the device. Once it's connected to the device, it'll pass the certificate into it. It'll install the certificate into that trust store. Once I install the certificate into the trust store, it's used right away by this microservice, and we can see that the actual API goes down, and then it comes into an Opera up state right away. That's part of this, is that we can install a certificate and it's used right away. The operating system API, I've used this a couple times since 17.5. We use it in our lab actually to upgrade between major versions before Cisco Live. It's a one-liner now that we send to this thing when we want to do software upgrades. The only thing we need to change is the bin file, and there's like a hash or a checksum that we need to compute. And it's a lot more programmatic. We just send one API call and we walk away. 20 minutes later, we come back and the thing's been upgraded. What does that actually look like? 2 or 3 CLIs or Linux commands that we send basically say, I want to verify the code that I'm sending you, and then I want to install and activate this code that I'm sending you. Very similar workflow to managing OS installs on iOS XE, where you have this like activate install type of process. But once it's done, you can see from the device here that we go from 17.5 to 17.6 by using these CLI options. The other, or the final operation here is the reset.proto. We also use this quite a bit in the programmability lab because we use ZTP. We actually factory reset our devices like daily or weekly almost between students or users in there. And it gets configured automatically or programmatically using the ZTP day zero feature. So we reset the boxes all the time. They do a zero fill where they zero out everything on all of the disks. So if any student left like any remnants on a USB flash drive that was inserted, for example, that gets completely zeroed out. And then it comes back up from ZTP with that golden image every time in the exact same way. So we found the reset proto to be very effective in our labs here. And again, you see, we're just calling gNOI reset. We're saying where we want to send that reset to, how we want to authenticate, if at all, and any of the options that we want to send. In this example here, you see I'm using 50052. I'm using a no TLS option, and I don't have certificate or user-based authentication enabled. The thing is just like straight up bareback out there. There's no authentication in front of it. gRPC tunnel. So I mentioned this at the beginning. This is when your tooling cannot reach your device. Okay, so if you have a network architecture where you have branches and you have centralized tooling, then this is an option that you can use to still have access to your network devices. What happens is the network device creates a session out of the network, connecting into the tooling, out wherever your tooling is listening on the network. The iOS XE device will make a gRPC connection or session to that. So then you can manage the device as if it were local to the tool. This allows us to bypass firewalls and get through network ACLs that otherwise prevent network connectivity. It's a little bit of a convoluted path that the packet takes when we're in this tunnel, but we basically go in this like tunnel thing, then we go all the way back around to the regular old listening port that we typically always go into, which is like 9339. That's where the socket is listening. For gRPC tunnel, we can also use MTLS, right? So you can have confidence that if you need to place this thing right out there on the internet, that you can do so safely and be protected by the certificates. Put some reference documentation in here about how to actually get started, turn on this tunnel, and do testing and validation with it. We have this in GitHub, so you can copy, paste, or clone this down and then be successful in proof of concept with gRPC tunnel. The tooling that we use for this is gNMI. gNMI is a tooling that's been out. It was originally crafted by Nokia and then taken over by the Google OpenConfig consortium and is now considered to be the de facto or the reference tooling for gNOI and gRPC tunnel. This is the example here. It's not very powerful in the screenshot form, but essentially we turn up the tunnel listener, we turn up the tunnel on the device, and then we send commands from our tooling to the device, and we're able to get, in this case, we're doing like a get against the host name, right? So we're just doing a very basic validation that API calls are working. And here's exactly what I'm describing, where we're highlighting that we're able to get an API call successfully back through this tunnel. Let's talk about Yang Suite, because Yang Suite is the tooling that's been around in Cisco for quite some time and has full support for the gNMI API as well. The gNMI plugin, it's a plugin to Yang Suite. So it shipped with the second release of Yang Suite when we released that a couple years ago. But when you install Yang Suite now, you'll see it installed by default. So some examples here of making successful API calls for Cisco native hostname, as well as for OpenConfig. So depending on the data model flavor that we're working with, there's some different options that we need to set, specifically the origin. We see the origin on the left side here, and in this example, it's set to RFC 7951. We use this origin for Cisco native data models, and if we're working with OpenConfig, then we change the origin simply to OpenConfig. The last example was a get, where we're just going to understand what the host name is currently set to. But now, of course, we want to change that, right? So we can change our operation from get to set put some value into that field, and now we can send this API call to effect change on the device and have an updated hostname. Hostname is just one example, of course. We can change this to any feature. Continuing on with hostname, though, let's look at how to change this using not the Cisco native data model, but using the OpenConfig data model. OpenConfig data model is shared between vendors, whereas the Cisco native is going to be specific to all the config knobs that are applicable only on your Cisco system. We can also get interface data as well from IETF, from OpenConfig, or from Cisco native. And this is the most common data model that I see 99% of customers look to, which is interface opper or OpenConfig interfaces or IETF interfaces. Simply how much packets, how much bytes, how much throughputs, what are the errors, what are all the counters for all the interfaces on my device. We get the response back when we ask for these IETF interfaces. Might be a little hard to see on the screen here, but it's basically telling us that on interface 40 gig 101, that we're seeing this much packets per second. Another example in here about affecting change, updating the hostname on here, same thing. We can go in, put whatever variable we want into Yang Suite, and then send the API call and confirm that the configuration has been updated. What about subscribe? Right, we've been talking about gets and sets. The gNMI plugin in Yang Suite also supports subscribe. So we can build the API call to be successful here so that we can then get data coming back to us, push to us, stream to us at whatever interval it is that we ask for in the API call setup, which is up here on the top. We have some options for the update interval. So if you want that every 10 seconds or every 60 seconds or every 5 minutes, we can set that in there and do the validation there. Another integration that we have from Yang Suite is integration with Ansible. Right, so you can build your API call to update the hostname or configure your feature, validate that it works in Yang Suite, validate it works against your device, and then you can export that to an Ansible play. You can then plug that into your Ansible tower or whatever orchestration or abstraction system that you have, and then run that against your entire inventory or your entire network. I have a demo of what that looks like in here, a recorded GIF demo. We're essentially going into the plugin. We're loading up the data model. We're in OpenConfig system hostname, right? So we're just going to go and update the system hostname. I've selected the hostname leaf, and I'm putting in, updated by gNMI. Once I put that in, I can build the API where I get this big JSON blob. And then I can send this API or send this RPC to the device. It gets sent, gets returned, and then we get to see the results. In this case, we're going to export the Ansible script. We're going to download it, move it over into our Ubuntu. There's a couple of things we need to modify in the playbook. By default, you need to put in the credentials and maybe the inventory information. But once we update that, then we can send the API call, actually trigger Ansible. It's going to go out to the inventory and make that change. And here's what we see. We've got the OK back saying that the hostname's been updated. So a really quick GIF demo here. Let me share some resources. If we have time, we'll go over to the live demo if I have network connectivity and can get on the VPN. But let me share some resources before that. As I mentioned, lots of sessions around programmability this week. I guess we're kind of towards the end, but these are all recorded available on the session catalog, and the slides are available. So I'm very happy to share that content with you. We have updated our programmability website on developer.cisco.com/iOS XE. Like we pushed publish like 4 days ago. It's like brand new. There's a bunch of content on here, specifically like learning labs, sandboxes, white papers, and code samples. We've updated and refreshed all of this stuff. So it's a lot easier to find updated and relevant information about the programmability lifecycle on iOS XE now. We've also published a white paper that goes pretty deep into the gNMI API capabilities, as well as the other APIs overall on iOS XE. So it's a really good white paper that you can reference when you're diving deep into this stuff. We also have a reservable training environment in Cisco dCloud platform. You can reserve this programmability and automation lab. It has 5 or 6 virtual Catalyst 9000 switches in there that have been configured with telemetry, with the API, with gNMI. Yank Suite is in here as well. So you don't need to install any tooling. You can just reserve the environment, jump in here, and be successful right away with working with the API. We also have a book sprint book that covers all these technologies at a pretty high level. You can just glance through this or gloss over this one. And then, of course, my nighttime or nightly reading material is the Programmability Config Guide. This is where I go to when anyone asks me any tough questions. So lots of really good resources in there. So with that, we're pretty much out of time, and I want to thank you here for joining me for this gNMI session.